Guys, hope you're all doing well today. I got a lot of requests today for a video on the second portion of the notes, which was this extra practice number 2. So our second big circle that we've had a chance to try out. So I want to actually go ahead and go through that with you guys. But first off, let's go ahead and identify the information you know. And here is what you are given. So you are given a few pieces of information here. The measure of arc JI is 62. We're given that here. The measure of angle A is 32 degrees, that's given here, and the measure of arc BJ is right there, okay? So we're going to go ahead, and that was 24. We're going to go ahead and figure out a few more pieces of information here. And that first one, which this may be where the confusion is coming from, guys, is that the line EG is actually tangent to the circle O at F. Now you guys got to remember something from that, guys. Here's the line EG right there. Okay, if it's tangent, that means it only touches the circle right there at F. Okay, why is that relevant, guys? Because if it touches it at F, also you have to remember when I have a tangent and a radius that intercepts both of those intersect right there at F, then actually these are going to be a right angle right there. Okay, they're going to create a right angle. Okay, so let's actually start off there, guys. We know that that has to be a right angle. So angle DFO is a right angle, which actually means angle GFO is also a right angle. Okay, so maybe that's going to be helpful, guys, and maybe where that some of the confusion started. But let's actually go through this, guys. And I actually like this big circle because the first thing they ask you to do is to actually find the measure of the arcs. Okay, so I like that because if you know the measure of the arcs, guys, usually the measures of the angles inside or outside, they become a lot simpler. So let's actually go through that. So the first arc they're asking us to find is arc CB. So that's this arc right here. Now, as I look at that, guys, there's really no angles that go through that, no angles that have that as an intercepted arc. But one thing I definitely see standing out and hitting me right now is this right there. Okay. Um, And you know that looked like a good strategy. Unfortunately, I don't have the entire semicircle. Okay, because I'm missing this portion right here. I'm missing that little HI. Maybe that wasn't that good of a strategy. Let's go ahead and try something else, guys. And that's how these are gonna work. You're gonna try something out. Maybe they work. Maybe they don't work. But eventually we will get it. So one of the things that is standing out to me, guys, that I see right away, besides that, maybe let's skip CB. I notice a lot of good information actually right here for angle A. If you look closely at that, guys, that angle A has a little arc right here. Okay, to find the measure of an exterior angle is always going to be the big arc minus the little arc divided by 2. Well, I have a little arc, I just don't have a big arc. The big arc would actually be this one right here, arc CF, which is something I'm looking for, so I may as well find it now. So let's do that, guys. We have some information here. We can apply that. So what do I know? The measure of the angle, actually we know that already, it's 32. The big angle, I don't know. Let's call that x for now. That's x. And then minus the little angle, which is, or sorry, the little arc, which is 0.4. And then I'm going to divide that by 2. Well, let's do a little bit of work here. First things first, let's get rid of this 2 by multiplying both sides by 2. That's how we undo a division of 2. That means these will cancel, leaving me 64 equals x minus 24. And if I add that 24 over, I'm going to get 88 degrees. Okay, so I actually just found the measure of our CF. It is 88 degrees. Go ahead and write that down, guys. Okay, so it's a little unclear as to where to start. As you guys saw earlier, I actually couldn't figure out where to start right away. And it happens, guys. You just have to keep analyzing the diagram. Okay, so we know that information. I'm going to go ahead and erase all this other stuff now. It's all extra now. Okay, but at least now I know that F is 88 degrees. Okay, let's keep going then. And actually, now I can go ahead and take this approach. I can go back to looking for CB. And here's how I'm going to do that, guys. Look at this That's a diameter. This is a semicircle. I have everything I need to just subtract 180 minus 88 and minus 24, because those are the arcs that I do know. I'm just missing that last portion. So 188, or sorry, 180 minus 88 and minus 24 is actually going to give me 68 degrees. So the measure of this arc right here, guys, is going to be 68 degrees. Okay. All right. So we found our next arc. Cool. Well, actually, remember, I'm going to actually go back to something that I mentioned earlier, guys. If you remember, I said I couldn't actually find, or I couldn't actually use this as a semicircle because I didn't know how much this measured right here. I don't know how much h I measured. Well, actually, I can use that now, okay? I can go ahead and subtract everything else. I can subtract 68, 24, and 62 from 180 to find out how much that actually measures. Let's go ahead and do that. That's going to be 64, sorry, 68, 24, and 62. That is going to give me a measure of, let's see, 26, I believe, 26. Okay, and actually, let me go ahead and pull up my calculator so we can check that. Okay, so here's my calculator, guys. Let's go ahead and check that real quick. 180 minus 68 minus 24 minus 62 gives me 26. Okay, so we were correct, guys, so let's keep going there. So the measure of arc HI is going to be 26 degrees. All right, cool. We're getting somewhere, guys. We're getting a lot of these arcs now, and trust me, guys, once we find all the arcs, the angles get much, much easier. So there's actually only, let's see, FH, and okay, J, F, H. So this is a bigger major arc right here that we can find once I actually find the measure of FH. I'm going to go ahead and find that one next. So FH is right here, FH, and once again, guys, what I could do here, well, I already know a lot of good information. I already know that this is still a diameter. The only other piece of arc there is this arc that I already know, which is 88. So all I have to do is 180 minus 88, and that's going to give me the angle measure, which in this case is going to be 92 degrees. Okay. 92 degrees, and now I have officially found all of the missing arcs, which again, guys, I promise this is going to make things so much easier. Um, the last thing, like I said, guys, it's actually a compound of a few of these. JFH, so let's see where that is. JFH. So actually that goes this way. Try to follow the order of the letters, guys. JFH. Because if you tried going the other way, guys, it would look like this. JFH. That wouldn't make any sense, right? So that's JFH, guys. So all I really have to do here, if you look closely at it, guys, all I really have to do is just subtract this and this from a full 360, because this right here is the remaining piece of a full circle. So all I have to do is 360 minus 62 minus 26, and that's actually going to give me 272. But let's just double check it, guys. Let's make sure that's correct. So 360 minus 62 minus 26, 272. So we were correct. Let's go back to it. 272. All right, we officially now have all of our arc measures. Let's start working with some angles now. So finally, we can get started here. Okay, let's move on then. So first angle I'm looking for is angle EDC. Where is angle EDC? Okay, angle EDC is right out here. Well, we haven't really talked too much about those angles out there yet, but what we have done, if you look closely at this guy, these are supplementary. Okay, those have to add up to E180. So maybe if I could figure out the measure of this angle right here, which is CDF, then I can go ahead and figure out what that measure of that other angle is. So let's go ahead and look for it. So Let's calculate this pink angle right there. Well, again, guys, use your highlighters if you have them to trace out the segments that create that angle. And if you look at it, guys, we do have some good information. We have a little arc here. That's the first piece of arc that it intercepted. And the second piece of arc it intercepted was this much bigger arc. So what is that purple arc? Well, let's go ahead and calculate it. Let's see. Oops, sorry. It's going to be 92 plus 26 plus 62 plus 24. Let's go ahead and write that down. So 92 plus 26 plus 62 plus 24. That's 204. Let's go back to it. So all that's going to be 204. So to find out the measure of that angle that's on the outside, remember guys, measure of angle CDF is going to be big arc, which was 204, minus little arc, which was 88. I'll even show you guys the highlighted and how I highlighted them here. And all of that is going to be divided by 2. So 204 minus 88 divided by 2, let's do that. 204 minus 88, and then that divided by 2, that's going to give me 58 degrees. So 58 degrees is the measure of this angle here. Okay, I'll do a little bit of erasing here. Let's go ahead and erase all this extra information. So while I didn't find the angle that I was looking for, I kind of did, because now I know, like I said, guys, these are supplements right here. These two are supplements. And if they're supplements, that means 180 minus 58 has to give me 122 degrees. So I found the angle EDC, 122 degrees. Now let's find EFC. So EFC, EFC, that's this angle right here in gray. So EFC, guys, you're going to find by, again, using the fact that that angle is created by these two segments, and the piece of arc that is trapped is 88. Guys, this is a tangent chord angle. Tangent chord. Okay, that's why it's called a tangent chord angle. And kind of like with inscribed angles, guys, to find that angle, you have to do half of the intercepted arc. So half of 88 is going to be 44 degrees. Okay, so this angle right here, this gray one, is going to be, and I'm going to make it a little smaller here, this is 44 degrees. Okay, all right, let's keep going. Next one. CDF. CDF. Let's see. Actually, CDF is one that we already found. We already knew that was 58. Right? CDF. We already found it was 58 degrees. Let me just write it a little larger. 58 degrees. Okay, let's go ahead and write that down. Next one is CFA. So CFA, where is CFA? CFA is right here. CFA. Okay, well, that looks like an inscribed angle. That looks like this angle right here. Well, what piece of arc does it intercept? Well, go from edge of the angle to edge of the angle, right there. So it's arc CJ. So that's the combination of 68 plus 24. 68 plus 24 is 92. So half of 92 is going to give me 46. So this is 46 degrees. Go ahead and write that down. Okay. You really just I think that's probably one of the biggest pieces of advice I can give you guys is just ask yourself what kind of angles do you actually have. In that case, we had an inscribed angle, so you have to find half of the intercepted arc. So just be careful there, guys. And actually, a quick little check for yourself. Check this out, guys. 46 plus 44. What is that? That's 90. Well, didn't I just say a second ago that this had to be 90? Okay, because it's a tangent line on a circle. So we just confirmed that, guys. We are on the right track. That's one way you should always confirm your answers. That way you don't make any mistakes later on and mess up the rest of the circle. So overall, good job, guys. Let's keep going. Now we're looking for GFI. Where is GFI? Okay, I see it here. GFI, also an inscribed, actually not an inscribed angle, sorry, a tangent chord angle, but it works very similar to an inscribed angle. So this tangent chord angle is right here. Let's figure out how much that is. Well, we gotta find out what the intercepted arc is, which is this piece of arc right there. So it's 92 plus 26. 92 plus 26 is 118, so half of that, half of 118 would be, let's see, 59 if I'm not mistaken, 59. Okay, let's go ahead and do, oh, I'm sorry, give me a second, guys. Did I look at the wrong one? Give me 1 second. Yeah, let's go ahead and double check that, guys. So we had, let's see, it was 92 plus 26. That was 118 and divided by 2. That gives you 59 degrees. So I was right. I just second guessed myself there. So this should be 59 degrees. Okay. So 59 degrees. Okay, cool. Let's move on to the next one. So the next one is going to be the measure of angle FJI. So let me do some erasing here. Okay. FJI is right here. And actually, if you look closely, guys, that intercepts the exact same mark. So that's also 59 degrees. 59 degrees right there. So that was pretty simple. We got lucky there. That's something we actually just learned. So FJI is also 59 degrees. Um, let's see, what was next? FAC. FAC. Uh, actually, FAC we were given, right? FAC. That's 32 degrees. We already had that. So we got lucky there again. So 32 degrees. OCA. Let's go ahead and do the next one. OCA. OCA. Well, we have some options here, guys. We can go ahead and actually, if you look closely at this, guys, this is still a diameter technically. So OCA. Okay, because that's a straight line. I could extend that there, and if I do that, I can see the intercepted arc, which is this part right here. So what I'm going to have to do is, again, this is an inscribed angle, okay, and it intercepts that piece of arc, which is 24 plus 62 plus 26. Let's go ahead and do that. 24 plus 62 plus 26 gives me 112, so I have to divide that by 2. That gives me 56 degrees. So 56 degrees. All right, let's go ahead and do some erasing here. So we found it though, at least, guys. This was 56 degrees. The next one is going to be FOH. So where is FOH? Let's see. FOH right here. And that's actually one we haven't seen in a while, guys, but we know how to work with that too. That's the intercepted arc. But this time, guys, that angle is not an inscribed angle. This is a central angle. So that's going to be exactly the same size as the intercepted arc, so 92 degrees. Okay, 92 degrees. Central angle is always the exact same as the measure of the intercepted arc. So the next one is going to be OKI. All right, where are you? OKI. You're right here. OKI. Ooh, that one's a little weirder. So that is this angle here. Okay, so we're gonna have to do some work with that one, guys. Now that's an angle that's inside of the circle. Okay, it's inside of the circle. So we have to check out which are the intercepted arcs. Well, I'm gonna have a big and a small one, but first I should probably trace out what are my segments that make that angle. That's the two segments that create that angle. So the first arc that I have is this one. Okay, that's the arc directly opposite of my angle that I'm looking for. And then on the other side, would be this angle. Okay, so we got to do some work here, guys. So the measure of angle, let's do some work here. The measure of angle OKI is going to be equal to the big arc plus the little arc divided by 2. So the little arc is definitely going to be 92. For the big arc, I got to add up, let's see, 68 plus 24 plus 62. Let's do that. 68 plus 24 plus 62, that's 154. So 154. If I add that up and divide by 2, let's see. 154 plus 92, that's going to give me 246. Okay, and 246 divided by 2 is going to give me 123 degrees. Okay, so 123 degrees, 123 degrees. Awesome. Two more, guys. So that is angle ACF, the one that is next. So let's do some erasing here. ACF is right. Oh, it's actually right here. ACF. Okay, well, let's see here. Well, in order to find that, I'm gonna need to, well, that's still an inscribed angle, guys, actually. Now that I think about it, that's an inscribed angle. What's the piece of arc that it intercepts? Well, that is this whole thing. So I can go ahead and do 1/2 of what all of that is. So let's add it all up. So here it is. 24 plus 62 plus 26 plus 92. And I think that was actually it. Plus 92. Yes, it is. So that is 204. So let's go back. The measure there is 204. Now remember, guys, that's the measure of this arc, 204 degrees. But we want the inscribed angle, which is half of that. So 102 degrees. So we found it. 102 is that. And then finally, JIF, the measure of angle JIF. Let's do a lot of erasing here, guys. Sorry, my diagram's getting kind of cluttered here. So JIF, last one. Here it is, JIF, and that one's going to be probably one of the more simple ones, guys. And the reason why is because of this. That's a diameter. And if that's a diameter, the intercepted arc is 180. So 180 divided by 2 is going to give me 90 degrees. Okay, and we're done, guys. Now, by no means was this the way to do it. It is not the way to do it. There's a lot of different ways to do it, guys, but hopefully this helped out those of you guys who were a little stuck. If I'm not mistaken, now that I'm looking back at my answer key, guys, I think this answer was incorrect in my answer key right here. I believe it said 46, guys, but the answer should be 59 degrees. For sure, it should be 59 degrees. And I know that, guys, because I could do a quick little check for myself. Let's double check that I'm right about that. If that's 59, then this actually must be 31 degrees. How come? Because this is a right angle, so that it should add up to be 90 degrees. And it does. Well, and one way I can confirm that is, finally, this is an inscribed angle, so 31 is an inscribed angle with this piece of arc trapped inside. So half of 62 is 31, so I just confirmed that this has to be correct. So not 46, guys. If you were confused by that, I apologize. I will change that, but the answer is 59 degrees for angle GFI. Okay, this video was a little longer than I thought it was going to be, but hopefully you guys are a little bit better off with this, guys. So a lot of different angles here, as you guys can see, a lot of different calculations. So just take your time, guys, and give it a shot. All right, I'll give you guys a few more of these as we progress through the week, but for now, guys, I will see you in the next one.